Hello and welcome. My name is Robert Llewellyn and I am the founder and one of the presenters of the Fully Charged Show and the Everything Electric channel. And I am proud to present another scintillating episode of Almost Breaking News. Now, just before we start, as many viewers will know, this channel is 14 years old this year. And for the benefit of our wonderful viewers outside the UK, one constant through that 14-year period has been the government of this country. Now, I don't want to talk about the last lot, they are gone. But we have just had literally historic landslide election, and now we have a completely new government with a very peaceful handover of power. In reference to this channel, we have to hope that they will have a slightly more progressive attitude towards renewable energy and the infrastructure needed to connect new projects to the grid. We have to hope they will see the benefits of community energy projects and, very importantly, ensuring that all new houses are built with excellent insulation, heat pumps, solar panels and batteries. One thing they are doing, though, which is very good news, is they are reinstating the ban on the sales of new petrol and diesel burners from 2030, which the industry wants and will encourage more cheaper, smaller electric cars to be on the market. So fingers crossed, and here we go. Love everything electric? Join us live in Canada this September, the South in October,
and Australia and London in 2025.
Let's start with a big old combustion car company with a mixed history regarding tailpipe emissions, who are now joining forces with a new small car company that have only ever made electric cars. In this case, Volkswagen and Rivian. They have recently announced their intention to form an equally controlled and owned joint venture to create next-generation electrical architecture and software technology. To put this in ordinary people language, Rivian have proven to be one of the best electric vehicle makers on the planet, and VW clearly know how to turn out mechanically well-built cars by the million. So joining together strikes me as very positive news. Next story. We all know that flying has an impact on our environment. However, in the grand scheme of things, it's very near the bottom of the list in terms of damaging human activities. Road vehicles account for 74.5% of CO2 emissions from global transport. Aviation accounts for 11.6%. But in terms of total human output of CO2, aviation only accounts for 2.5%. How hard is it to eliminate fuel in ground transport? It's quite easy. How hard is it to eliminate burning fuel in aircraft? It's very, very difficult. But all that aside, there are teams, research groups and companies all around the world developing battery and hydrogen-powered flight. And although we've been mentioning the notion of electric vertical takeoff and landing craft, eVTOLs, for a long time, it does appear that these new machines are approaching reality. As a mere 6-year-old company, Archer Aviation from San Jose, California, have a fairly impressive record. They recently reported that their flagship Midnight eVTOL aircraft had received a special airworthiness certificate from the Federal Aviation Administration, the FAA. This means the aircraft has met all FAA safety requirements and can begin actual proper test flights. The aircraft is a piloted 4-passenger air taxi designed to carry passengers on short trips of around 20 miles or 32 kilometres between airports and downtown city areas. I think it's going to be very popular for fairly wealthy people to use these aircraft, zipping from a central city area to a nearby airport. I agree, it's cool and innovative. But getting a train from a city centre area to an airport would probably be just as quick and a lot cheaper and less energy intensive. But all that aside, what fascinates me is no one would have considered trying a totally new design and a totally new technology in aviation before the introduction of energy-dense batteries and incredibly small, light and powerful electric motors. We obviously are going to see systems like this in the air in the next 5 years. They will become more and more common. I just can't help thinking that the business case is for very wealthy people. Next story. Let's talk investment. That's a really serious topic. Now, this is quite astonishing. According to a very recently released report by the International Energy Agency, the amount of money now being invested in solar power outstrips all other spending on all other traditional power generation combined. Scrape it all together, all the coal power plants, all the gas plants, all the nuclear, it's all being outstripped by the investments in new solar. And 40% of that new investment comes from households. Domestic solar installation has never been higher. All over the world, people are fitting solar panels to the roof of their houses or businesses. The IEA estimates that in 2024, total spend by all energy generation globally will exceed $3 trillion. And around $2 trillion of that will be on solar, wind, battery storage, grids, electric vehicles, low-emission fuels, efficiency improvements, and heat pumps. We are seeing a massive global shift. And just for balance, we have to remember that intelligent, well-educated human beings will also spend around $1 trillion on coal, gas, and oil-burning power generation. You know, just to keep things balanced. Oh, God. Next story. In the last news episode, I mentioned a new form of concrete that could store heat. And now there's a new form of concrete that can actually store electricity. Yes, we are talking about a battery made of concrete. What the what? Researchers at the Massachusetts Institute of Technology have discovered that by adding a highly conductive substance called carbon black to a water and cement mixture, they created a construction material that could also serve as an ultracapacitor. Well, what's an ultracapacitor? It's a simple battery that can store huge amounts of electricity very quickly for short periods and then deliver that electricity very quickly, many hundreds of thousands of times without any degradation or capacity loss. We made an episode about skeleton ultracapacitors about 5 years back, so if you're interested, there's a link to that episode in the notes with a lot more explanation of the role of ultracapacitors. However, the point is this: if this new concrete proves to be a plausible building material, you could build a house that could, with the right technology, store all the excess solar power you might produce, but store it in the actual structure of the building rather than a battery box strapped to the wall. Then imagine if all new buildings used this concrete and all the solid structures around us were also batteries. And then imagine that the road surface is made of energy storing concrete. You could, according to the researchers at MIT, not only store electricity, but also deliver it to vehicles passing along the surface. Those are the ideas the people behind this project are exploring. And once again, it may be a pipe dream. It may come to nothing. But the amount of innovation, new materials being developed, and the engineering exploration around projects like these shows that something big is shifting. That is what's made the last 14 years bearable under the previous administration and also so fascinating. And I think the next 14 are going to be even more exhilarating. Next story. How many times have we discussed the fact that electric cars are still more expensive than petrol and diesel models? Too many times is the simple answer. Well, this report from Bloomberg has revealed a change that is fairly dramatic. It is now the case that in the United States of America, new long-range electric vehicles are cheaper to buy new. When you go to the showroom and buy a new car, they're cheaper than buying the average new fuel-burning combustion car. They are cheaper, not more expensive. We've got to keep repeating that. They are cheaper. Send it to your annoying uncle who always says, more expensive. Now, this is due to many things, the main one being the incredible competition in the American electric vehicle market. Tesla, Hyundai, Kia, and General Motors have all slashed prices of their new electric models. This has mainly affected the higher-end models with 300-plus miles range. But as this graphic clearly shows, the price of old-fashioned combustion vehicles has been slowly climbing, whereas the cost of new electric vehicles has literally fallen off a cliff. And remember, this is in a country with truly punishing tariffs on imported, cheaper Chinese vehicles. But this price-cutting race has resulted in a few surprises. A drop in sales for Tesla and a massive increase in sales for just about everyone else who's ever made an electric car. And this is just the start, or so claims the CEO of the Stellantis Group, Carlos Tavares. He said the automotive industry is going through a very challenging period. Very chaotic, he said, very Darwinian. He added, it's not, watch out, there's a storm coming. We are in the storm, and the storm is going to last a few years, and it's going to put a number of companies in trouble. Now, I haven't used the term disruptive technology for a while, but that's what we're seeing with electric vehicles. It's a massive global disruption of the once dormant but very stable automotive industry. Literally anything could happen. Next story. We've covered some battery electric trucks over the last few years, some more plausible than others, but all very impressive. We've also heard since the show started in 2010 that hydrogen is the future, and it seems so far that has sadly proven to be a bit of a dream. However, it has always made more sense to try and use hydrogen fuel cells as a power source for large vehicles like buses and trucks. For example, there are 20 hydrogen fuel cell buses running regularly in London. Okay, in contrast to the more than 1,000 battery electric buses, and as I mentioned in a recent episode, Transport for London have just ordered many hundreds more. But in news from Switzerland, Hyundai have run 48 fuel cell heavy-duty trucks, a combined total of 10 million kilometres or 6.5 million miles. These Exient fuel cell electric heavy-duty trucks started work in Switzerland in 2020 and have been proven to be incredibly reliable. Their range on a full high-pressure tank of hydrogen is around 400 kilometres or 250 miles-ish. But here's the really important bit of this story. These trucks only use green hydrogen, which is, as I'm sure you all know, hydrogen that is derived from splitting water in an electrolyzer using power from either wind, solar, or in the case of Switzerland, copious hydropower. No steam methane reforming out of natural methane gas for this project, because for me this is the massive question about hydrogen fuel cell vehicles. Where does the hydrogen come from? Today, 90% of commercially available hydrogen is produced by steam methane reforming using a fossil fuel in a process that releases tons of CO2. Anyway, it's great to see Hyundai developing this technology, and clearly there are going to be some markets where this technology flourishes. And for those of you cynical about hydrogen fuel cells, let me just say, it's better than a diesel truck. Yes, better, but probably not going to change the world, because this story has also just emerged. The engineering group Danfoss Power Solutions drove one of its Class 8 electric trucks from the company's headquarters in Nordborg in Denmark, got that right, to Le Mans in France in time for the start of the recent 24-hour of Le Mans sports car race. That's a distance of over 800 miles or 1,287 kilometres. That is a lot further than the hydrogen fuel cell truck I've just talked about. Now, this truck can travel just short of 500 miles or 800 kilometres on one charge. So it actually only needed to stop once to top up its batteries on that journey, and all it needed to do that was electricity and a high-speed charger, not a massive new electrolyzer and enormous high-pressure hydrogen pumps and a tank and all the adjoining infrastructure. I'm just saying. Next story. Now, what do we do with all these fancy pants batteries at the end of their useful life in a vehicle? We're literally going to throw them away. When we started the Fully Charged show 14 years ago, this was literally a theoretical question. How do we use those batteries again? There were probably a couple of thousand electric vehicle batteries in the world back in 2010. There are now well over 400 million. And that, dear viewer, is a lot of battery. Of course, many people are clearly under the impression that when a battery in a vehicle has lost capacity, making it non-viable for a vehicle, it's totally dead. It's just a piece of rubbish, you've got to throw it away. I've been told that countless trillions of times. However, the truth is, it's probably at 60 to 70% of its original capacity, which means, and even I can work this out, if the original battery had a 100 kilowatt hour capacity, it will still be at 70 kilowatt hours when it reaches the end of its useful life in a vehicle. And 70 kilowatt hours is, by any standards, a large amount of electricity. If I had a 70 kilowatt hour battery at my house, and remember everything in my house is electric, no gas, then that battery would last me 3 or 4 days of total grid blackout. The sun's gone out and all the grid's stopped and there's a zombie invasion and I could still boil a kettle. So, where, you might ask, is the stunning example of using ex-vehicle batteries in large-scale electricity storage installations? That's a very good question. How about huge capacity batteries near old coal-burning power plants where the grid connection is already in place, which is exactly what they've done at power stations in Lünen and Elverglinsen, not far from Dortmund in Germany. This is actually nothing new. These facilities were installed back in 2016 and have been in use on a daily basis since then. But here's something that is new. Mercedes-Benz, GTEC Energy, and the Mobility House, who are running these old vehicle batteries, are extending the life cycle of their 2 large-scale stationary storage systems by another 5 years. That means that after the battery in your car is a bit ropey and annoying, and we're talking about after you have travelled 400,000 kilometres minimum, that battery has a useful second life of at least another 13, possibly 18 years. All I ever get asked about is, can you recycle batteries? Which of course you can, and this is already happening. But that recycling will only take place after the double life of a battery pack. I think it's perfectly plausible that a huge amount of the batteries we have in the millions of electric vehicles around the world today will still be in use in 30 years' time. That's 2054. If I'm wrong and YouTube is still in existence, you can leave a comment to correct you. Okay, I'll be 98 years old and still making almost breaking news episodes, but I will be a brain in a jar. Next story. Politicians in Europe and the USA are adding punitive tariffs to imported Chinese electric cars. That's a good idea, isn't it? You know, I mean, it protects the local industries. It keeps electric cars expensive and it stifles innovation and competition. So I'm just listing the negatives. That's really stupid of me. The thing is, we have been banging on about the arrival of really well-made, technologically advanced Chinese electric cars coming into Europe for at least 6 years. And it seems it's only been the last 6 months that our press has finally been aware of it. Just to put a little bit of context on this, for many decades, European car makers have been selling cars made in Europe in China. They sell them to China. I've been around numerous factories where I saw the cars coming off the production line and was told these are all going to China. This year, the 3rd biggest market for European-built cars is still China. There are shiploads of cars we make in Europe that are sold in China. Big deal. That's globalization. But clearly, it's a little bit unbalanced at the moment. For example, in 2023, 11,499 battery electric cars were exported from the EU to China, valued at around 852 million euros. But the same year, 438,034 battery electric cars were imported from China into the EU, valued at around 9.7 billion euros. There is enormous amounts of trade between China and the rest of the world. I bet your socks and t-shirts were made there. Definitely your phone, your laptop, your tablet, your router, the storage devices, the LED lights, the solar panels, the home battery. The list is endless. So the EU is talking about adding varying levels of extra tariffs for different manufacturers. Basically, the EU is saying the cost of making the cars is subsidised, which makes it unfair on European manufacturers. There's definitely been direct government policy in China to encourage manufacturers to make electric vehicles. But that was a decade ago. They claim the cars are not subsidised. China argues that its growing export reflects the country's natural competitive advantage and the high quality of its companies' products. Far more well-informed observers than me think that there is some truth in both perspectives. Chinese EVs have indeed benefited from massive industrial policy support in China, and their quality is improving, making them attractive to domestic and overseas consumers. So you'd think all the bosses of all the big European car brands would fully support these new tariffs. But no. Carlos Tavares, once again, the CEO of Stellantis, has criticised the EU tariffs on imported Chinese cars and said they preferred to fight to stay competitive. Likewise, VW, who have publicly expressed concern that the EU tariffs on Chinese electric vehicles could escalate trade conflicts, and said the European Union is promoting an ongoing trend towards protectionism, nationalism and isolationism. This is Volkswagen. BMW head honcho Oliver Zipse has also waded in. He is very concerned that China will retaliate with tariffs and restrictions of goods coming out of Europe. China is BMW's second largest market after Europe, accounting for nearly 32% of sales in the first quarter. I mean, it's difficult, isn't it? I drive a Chinese-built MG4. I would never have dreamt I'd be driving a Chinese car 20 years ago. And all I see on the roads of the UK are MG4s all the time. They are really common. They are really popular. And I'm seeing increasing numbers of BYDs. And yes, President Biden in the United States has added 100% tariffs on Chinese electric cars coming into America, thereby pretty much stopping all sales. But the USA has a very large car manufacturing base, and they import vast numbers of cars from Japan and Korea. So it's kind of a different situation. But clearly this challenge is not going to go away. Whenever we review a new Chinese car that's coming to Europe, we get a lot of comments from viewers in the USA saying they wish they could buy these cheaper, smaller, more efficient cars in America. Something we will keep an eye on, I'm sure. Okay, last story. Now, some of you will have heard of Lazard. They are a massive US investment bank, not an activist organization or a vegan academic with an axe to grind or a loudmouth show-off like me. They are, to put it plainly, a right bunch of bankers who can do proper mathematics and really, really big spreadsheets. They have recently produced a report which states quite clearly that renewable energy systems, primarily wind and solar plus battery storage, is the cheapest way of generating electricity. For onshore wind, which everyone should know is the cheapest way of generating electricity, they came up with the average figure of $50 American per megawatt hour, in contrast with coal being $168 a megawatt hour and gas being between $45 and $108 per megawatt hour. These prices are from a variety of locations around the world, and I repeat, their cost of onshore wind includes energy storage systems to ensure a 24/7 supply, not just the wind turbine, but enough batteries to make sure that whoever's taking the electricity from that wind turbine can take it 24 hours a day, 7 days a week. That is very, very important. That is what this price is based on. Utility scale solar came out slightly more expensive at around $62 per megawatt hour, with storage guaranteeing 24 hours a day supply. But that can be as low as $29 per megawatt hour. And remember, I'm going to say it again, these prices are since the massive increase in interest rates caused partly by the ridiculous price volatility of methane gas due to Uncle Putin's tantrums. The real loser in terms of cost is, of course, nuclear. According to Lazard, not me, Lazard, the bankers, the average cost of a megawatt hour generated by a nuclear power plant is $182 per megawatt hour. Just a little reminder, onshore wind is averaging around $50 per megawatt hour. So nuclear is $132 a megawatt hour more expensive. And while I've got a moment, I just checked on how our new massive nuclear power plant is progressing just down the road here in the UK. Hinkley Point C. Oh, dearie me. The project was announced in 2007 with a completion date 10 years later and a cost of £9 billion UK. So it should have been all done and dusted in 2017, and it would now be spaffing out 3.5 gigawatts 24 hours a day. However, it remains unfinished. The latest estimated completion date is 2031, and it's now going to cost £35 billion. So that original estimate back in 2007 was only £26 billion out. Be kind. We can all make mistakes. I do regularly. Anyway, that's all. Please do tell your friends about the Everything Electric show. Please do subscribe. Please do watch the Fully Charged show. Please, if you can, come along to our live shows in Canada and in the UK and Farnborough coming up later this year, and in Sydney early next year. But until then, as always, if you have been, thank you for watching.